and that's what I'll post on YouTube. But I'll also post the Zoom. So I've got like 2 recordings going at the same time here. All right, well, here we are. Y'all ready?
Ready.
Okay, for those of you who are at home, I'm not really going to look at y'all too much, but please just say something if you have a question. Welcome back to Cal 2, I guess. So y'all ready to get into integration by parts some more?
Ready.
Yeah.
Okay, so last time what we discussed, now I have to work between here and here, okay? That's where I have to stay to keep everything on camera, which is fine. I've done this many times, so. We discussed the integration by parts formula, and I just want to put it back up here. And I won't go through where it came from unless anyone has questions. I think I established that last time. It comes from the product rule, right?
Oh yeah, you already showed that.
Yeah, so I showed it, so I don't need to go through that again. So the idea is that if we have an integral u dv, that it equals u times v minus the integral of v times du. Ooh. Okay, that's the main formula that we're going to use. Now, I talked about the idea that the main idea of this formula is this thing called transferring the derivative. So you're kind of starting with, in the first integral, you're starting with some function, u, this is a good marker, u, and then in the new integral, it's the derivative of that, right? So we've transferred the derivative from u over, right? And then here is dv, and then that gets converted to v. So let's do an example. I know we did one last time, but let's do an example where this is going to be a basic example where we can see this formula in action. Then we're going to see that there are other versions of integrals that we use this formula, but it's not as obvious, all right? So our first example here, if it's all right with you, I'm just going to erase this and put this on the side, off screen. Everyone has it. Integral u dv equals u times v minus integral v du. All right, so the first example, let's do the antiderivative of x. Let's go with sine of 10x dx. Y'all can see that from home? That's all right? Okay?
Yes.
Good. So we first have to make sure there's nothing we can do that's obvious, right? Like some basic thing from Cal 1. Oh yeah, the antiderivative, that's this. And I hope it's obvious, right? If it were just that, we could do it, right? And if it were just this, well, obviously we could do that. But we cannot do them separately, right? We cannot split them up into 2 because we have a product between the 2, all right? So we have to do something else. So this is where I'm going to look at the integration by parts, and I'm going to say to myself, okay, if I choose one of these to be u, then in the new integral, it'll be its derivative. And then that forces the other part to be the dv, and in the new integral, it'll be the antiderivative of that. So is it obvious here that that should be the u? Because in the new integral, it'll be just the derivative of that, which is 1, right? And that would force this piece to be the dv. Now, that includes the dx. The dx is part of this because this represents the derivative of some function v. So I showed you all in class last time that I like to do it this way. I like to set up a table. I like to just put u here and dv. Those are always the 2 things that I'm going to establish that I get to pick. So I'm going to pick x here, and then everything I see there, sine 10x, sorry, I forgot the x, dx. And then to complete the table, anytime you come down, you take a derivative. So the derivative of u is dx. And then to go up on the table, this is the antiderivative. So the antiderivative of this, who wants to give me the antiderivative of that carefully? Negative cosine of 10x. Bree, right? Bree?
Yeah.
Okay. You know, I've been teaching for 20 years, and when I have normal face-to-face classes, I have such a hard time learning names. Such a hard time. But with Zoom, I kind of know some of you because your names, you know? I don't want to be all cheesy and have you like put your name on the desk, but okay, so Bree, that's almost right. There's something off. Think about the chain rule. We did discuss this last time. If you have AX in here, right, you have to account for when you take the derivative of this, you're going to have a chain rule and hit that. You're going to get a 10 to pop out, right? So you need to kill it off. So out front, 1/10. So negative 1/10 cosine 10x. That good, everyone? Okay? No questions? So now we just go straight to the formula, all right? And when I look at this table, I think of two things. I'm going to do these two across. That's ultraviolet. That's this right here, UV, right? So I'm just going to write those down next to each other. And this is what this integral becomes. So I'm going to put, watch the way I do this, negative 1/10 x cosine 10x, okay? So I decided to just slide the x right here next to the 1/10. And then I have minus the integral, this is our new integral, and now that will always be these two multiplied together. So it'll be negative 1/10 cosine of 10x and then times dx. Now, do y'all see right here when I took the derivative of x, I didn't put 1? Right, I put dx. You could put 1 dx, but you need to have the dx because when you do this multiplication, you need the dx to appear in the integral. Okay, we good? All right, so now we look at that new integral and we see, can we handle that integral? So let's see. Rewrite it again, negative 1/10 x cosine 10x. And I'm going to do a couple of things here. Negative and negative, right? I can pull this negative 1/10 out and make it a plus. So I'm going to say plus 1/10. Now the new integral cosine of 10x dx. Sorry, it's been over a year since I've written on a board, so I'm kind of like writing a little big here, but I'm also trying to make sure it comes out on camera. All right. So we can now do this one, right? This one we can do because it's just cosine 10x. So who wants to give me that one? Someone else.
Sine 10x?
Okay, this will be sine 10x. Be careful because you also have to account for the 10 inside, right?
Negative sine 10x.
Oh, careful. You're right. The derivative of sine of x is cosine of x, right? So you don't have a negative. Let me just write it down here. You had the 1/10 from here. This is going to be sine of 10x. But see, if you take the derivative of this, you're going to have to take derivative of what's inside also, that 10 again. So you have to account for that, right? So you have to have a 1/10 out here again. Is that okay, everyone? Or no? Now I need a plus c. I'm going to get rid of this. Roman, was that okay? You understand that 1/10 there?
Yes.
Okay, okay. Okay, so plus c, and then now we're done. We just write it all. Let's see, the 1/10 and 1/10 is going to become 1/100th, and then sine of 10x plus c. There it is. Box it up. That's the answer. Now, the only way to verify that that's correct is to take the derivative. And if you took the derivative of this, you would have a product rule right there you'd have to worry about. But when you do everything together, do all your derivative, you should get back this. So, any questions? Okay, you sure? We're going to do another one. Today it's all doing this. Oh, I sent out an email before class with a copy of an exam that I've given in the past. And that's just a review for you, all right? Just so you can look over and kind of see what types of questions I asked on exams. Your exam is scheduled from a week from today. And I put on there that I'm going to expect everyone to be in class for that. So, oh wait, a week. Hold on. It's on the 13th? It's on Monday. This upcoming Monday. Yeah, okay. So, yeah. What did I say on the email? Did I say Monday? I said the date. I said Monday, right? I don't think I put a week. Maybe I did put a week from today, but. All right. Now, next example. That was pretty okay, I guess. Get to take care of that little 10. Okay, how about this one? Antiderivative of x squared times e to the x. I think I explained to you all about this before, that one of the challenges, maybe not on this test, but on the next one, is that when you have an integral, you don't really know what technique to use. We really only have one technique for this test. It's integration by parts. And then we have, two techniques. U substitution, basic U substitution. And then we have this. And then just like the general stuff, right? That's what we have. So when you look at this, maybe you start thinking U substitution first. I don't know. I mean, I see that if you look at x squared, the derivative of that is 2x. And I have an x, don't I? So I'm off by a constant, but what's wrong with that? What's wrong with that idea? If that's, I'm doing basic substitution, not integration by parts, not that. If I look for something, right, and its derivative off by a constant, I have it. But what's wrong with that? What's wrong with where the derivative is? It's up in the exponent. Remember when I said it can't be trapped, can't be in the denominator? When I say trapped, I mean it's up here in the exponent. So you have to be able to take the derivative part and be able to slide it off to the side. So that's not going to work. Do you all understand that? So the only other thing we have is integration by parts. So we have to choose our u and our dv. So let me just do the table first. And maybe the table will kind of motivate where we go. So what's one choice I could have for u? What's one choice? I could use the x squared. Let's do a comparison. Let's do two different ways. Okay, because you really kind of only have two different ways, or you really only have two ways to do this problem. So this will be a comparison, right? So we could let u be x squared, right? That would go here. And then that would force the dv to be the e to the x dx, right? That's option one. Option two would be to do it the other way around, where we let the e to the x be here and the x squared here. Now, we don't want to just blindly, just do it. We want to be thinking about what the new integral is going to be. And that's where this whole idea of voodoo comes in. Because you need to be thinking ahead, what is voodoo going to look like? And can I integrate it? Can I find the antiderivative of it? Does it get better? So voodoo. Well, voodoo is these two pieces, right? These two. So I need to maybe fill out the table to see what they are. So this is du. That's 2x dx. And the antiderivative, what's the antiderivative of e to the x? Itself, right? E to the x. And then on this table, if I did it this way, the derivative of e to the x is itself, right? And then what's the antiderivative here? Careful, antiderivative. 1/3 x cubed, right? Okay. So now, thinking about voodoo, right? Thinking about voodoo, we have this one, and we have this one. Let's say this is option A, and this is option B. Which option looks better to you? What would you rather integrate in the new integral, A or B? A, why?
It's just easier.
Yeah, it looks nicer, doesn't it? This looks nicer. It'll be e to the x times 2x. This one actually got more complicated, didn't it? We started with x squared e to the x, and now we have an e to the x, but then we're going to have a 1/3 x cubed. The power's gone up. That's not good, right? So we're going to go with the first option, all right, because it looks better. and then we're going to rewrite everything. Here we go. So this now becomes, so do y'all see what I mean? It's not just like a blind, let me just pick and go with it. It's, you want to be thinking about what's going to happen, right? Okay, so we're not doing this one. So just using the formula, ultraviolet, so I multiply these two together first. So x squared e to the x minus the integral, and now voodoo. This times this, so I'm going to write e to the x times 2x dx. All right, that's the new integral. I can't believe my laptop didn't come on. All right, equals. Okay, now, when we look at this, I hope you recognize that we can't do this one either, right? For the same reason we couldn't do this one. We cannot do them individually, right? That's a major breaking of rules here. You can't just do them individually. And it's not something that we know, and it doesn't look like it's a basic U substitution either. So what do you think we're going to need to do? Do it again. Because the idea here is that, and this I think is, if you're going to take one thing away from this problem is this. If we take a step back, right, and we say, look, if this is U, right, and this is dv, then in the new integral, right, in the new integral, the power on this is going to come down, right, and integrating that doesn't change it. So in the new integral, I should get an x and an e to the x, which I have, x e to the x. Now the 2 can just come out, that doesn't matter. If I do it again, right, if that's my u, I can bring the power down again, which would take it to a 1 or a dx, and then this would be integrated, and that would just be e to the x again. Do y'all see how that? I'm going to repeat the integration by parts to kind of chip away at the power on the x. If this were an x cubed, I would know that I have to do it 3 times. X to the 5th, I might have to do it 5 times. That's just, but you could do it, right? You could just continue to repeat the process. Okay, any question?
So integration by parts within integration by parts.
That's right. We're going to have 2 layers of integration by parts here. So before I do it, let me do this. We're going to, I'm going to take the 2 out. I'll go ahead and do it. I'll just write it. X squared e to the x minus 2 integral e to the x times x dx. So that's where we are. I just pulled the 2 out. Now, I'm going to put this integral in brackets, and I'm going to go over here and I'm going to work that entire problem as if it's its own. And then when I get done with it, I'm going to bring it back here and stick it right there. Okay, so this is like a brand new problem now. Since it's brand new, I'm going to do a different color. Let's go. Here we go. E to the x times x dx. And I realize that blue is not coming through as good. Okay, so same thing. I need to make a little table here. Choose my u and my dv again, and then go through the process. So I'm going to let u be what? X, and then dv is the e to the x dx. I complete the table here. Du is dx. And I integrate up here. V is e to the x again. So there's my little table for that. Now I rewrite this using the formula again. So remember, this is going to have its own ultraviolet minus integral voodoo again, all right? So this becomes ultraviolet, these 2 multiplied, minus the integral of voodoo, which is the diagonal here, these 2. And now we're very happy to see this, right? Because this is just e to the x. And the antiderivative e to the x is itself again, right? So I'm not even going to go over there yet. I'm just going to go ahead and take care of this. I'll go ahead and put plus c now because I've actually done this. So this is going to replace what's in the blue brackets over there. Any questions? I'm almost done. Okay, so here we go. This now becomes, okay, start with the x squared e to the x minus 2, and then I had a bracket. You could use a parenthesis, it doesn't matter. Okay, all of this. So x e to the x minus e to the x. And then look what I'm going to do. I'm going to put the plus c out here. Doesn't matter. The constant can just push way out to the side. Even if you put it in the bracket and distributed a negative 2 to it, it's still a constant. We don't know what it is. So I'm going to go a little further and see if this cleans up at all. See, x squared e to the x minus 2x e to the x plus 2e to the x plus c. So just distributing the 2 through, the negative 2 through. And this should be it. Which we could check to see if it do you think that gets us back to x squared e to the x? So I think you can appreciate this now a little bit more. Like in Cal 1, right? If you're asked to take a derivative, we have these rules, right? Product rule, quotient rule, chain rule, all that stuff. We have it. Going backwards is different because the antiderivative of that is this, which is very complicated, right? So, unfortunately, there's not some real quick formula. I'm going to check it. I just feel like checking it right now. I'll do it in red. I'm going to go real fast, though, okay? So here we go. I'm going to take the derivative of this. I'm going to have a product rule there, and this one's no product rule. So derivative of this would be 2x e to the x plus e to the x times x squared. That's product rule on this. Then I guess I'll do it this way. I'll do minus. So I'm just going to ignore the minus and then do the product rule here. So that would be 2e to the x plus e to the x times 2x. Okay, that's my product rule on that, ignoring the minus. And then that right there is plus, the derivative of that's just 2e to the x. Okay, let me distribute this minus through. If I distribute the minus, that becomes minus, that becomes minus. There we go. There it is. Okay? So that's the original integrand. So just verifying that what we did works. Okay, yeah, so you can't, Cal 2, you can't just look at it and be like, oh yeah, the antiderivative, that's blah, 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 and just spit it out. I mean, it's just, if you can do that, then we should maybe talk about getting you into a different level of math. Okay, here we go. So look, the first problem was just, hey, we did integration by parts. Yay, we know how to do it. This one is like, well, hey, sometimes you might have to do it more than once, right? Now let's look at another type of problem. The antiderivative of natural log x. I'm going to let you look at that for a minute, and I want you to kind of think about what's different with this one. Oh. So what's different here? What's that? Yeah, it's kind of like only one thing, isn't it? Like up to this point, we've been able to say, oh, you've got u and then dv, and it's kind of obvious. Not obvious, but there's two things that it looks like to choose from, right? Here we kind of only have one thing, natural log x dx. And let's just verify also, you don't know the antiderivative of this. Everyone here knows the derivative of it, right? 1 over x, but the antiderivative is something else. So if you looked on your formula sheets, it's actually on there. But, hold on, don't get them out. Don't get them out, because where'd that come from, right? Where'd that formula come from? So it actually is integration by parts, okay? So this is your first example of seeing a problem where it doesn't look like integration by parts will actually do this, but it will, all right? So let's do it. Let's try something. We have to try something. So what do you think we use for u? Natural log of x. That's kind of the only thing we have to choose from, right? Natural log x. But then what does dv have to be? This is important. What is dv going to be? You have to have everything up there. So the dx, which is like a 1, but this is the dx. Okay? In the previous problems, whatever we used for dv, it was like whatever, the e to the x, we wrote e to the x dx on the previous problem, or in the one before that, it was the sine of 10x dx. The dx was always there. Here, we're just going to use the dx right there. And now let's complete the table. So we can take the derivative here, right? Take the derivative here. This would be 1 over x dx. And then we take the antiderivative here, and we get antiderivative of 1, which would be x. Now look at voodoo. Is voodoo doable? Is voodoo doable? Well, what's 1 over x times x? Is 1. Do you feel like integrating 1? Absolutely, right? This is going to be a good integral. So let's just finish it up. This should be ultraviolet, this times this. So x ln x minus the integral of this times this. I'll write it out, even though it's going to turn into a 1. The antiderivative of 1 is x. There it is. Now you can look at your formula sheets. Your formula sheet will have that on there, right? And we could check it ourselves by taking the derivative, and that's a product, so you'd have to do a product rule here, and then get that, right? Make sense? Any questions? Y'all want to see another one kind of like that, where it's not like super clear? We can do one. Why don't I let you see if you can do this one? Hold on. Do I really? Yeah, I'll let you. I'll let you. Yeah, this is a good one. What's the antiderivative of arc sine of x? Not the derivative, the antiderivative, right? I'll give you a minute. You can talk to each other if you Y'all making any progress here? No? Unfreaking believable. Oh, shoot, I'm sorry. I thought I said, can y'all hear me? No? Y'all can hear me now?
Yes.
Okay, sorry. Okay, so, yeah, so we take derivative here. This does not look very nice. The only other way we could have set it up would have been this, to put the sine inverse of x dx here. That's the only, but then the problem with that, there's two problems. What do you put here? Well, you could put a 1, right? Because there's always a 1 there. But then what's the derivative of 1? 0, and that wouldn't work because if du is 0, then voodoo would be 0. That's one problem. The other problem is what's the antiderivative of this?